Okay, solving a one-step word problem using d equals rt, distance equals rate times time. Okay, for these problems, I find that it's easiest way to do this is to make a table. So we're gonna do rate times time equals distance. And typically we're talking about two objects. So let's say object 1 and object 2. So when we fill out these tables, a little bit. We will do this times this equals this. So it's a multiply here and it's an equals there. So distance equals rate times time. This chart typically works for the problems Alex asks. Okay. So first problem. So two trains leave stations 440 miles apart at the same time and travel toward each other. One train travels at 105 miles per hour while the other train travels at 95 miles per hour. How long will it take for the two trains to meet? Okay, so I'm going to start making my chart. We have train 1 and train 2. So the rate of train 1. Train 1 is 105 miles per hour, so that's the rate. While the other travels at 95. And now the time we don't know. So we're going to call the time x, or you can leave it t. So in this problem, we're going 105 miles per hour, time we don't know, 95 miles per hour, time we don't know. So when we multiply these together, we get 105x and we get 95x. Okay, because the trains are traveling towards each other, and that's the way they stick with in this problem, this type of problem, is the distance 105x train 1 plus 95x, because they're both traveling towards each other. You add up their speeds and time, and that's going to equal the distance that they have to cover, which is 440. So we get 200x. 105 plus 95 is 200 equals 440. Okay, it says do not do any rounding. How long will it take for the two trains to meet? So we're going to divide both sides by 200. So 440 divided by 200, and we get x equals 2.2 hours. Okay, let's take a look at a second type of example. Same chart we're going to use. Miguel drove to the mountains last weekend. There was heavy traffic on the way there, and the trip took 10 hours. When Miguel drove home, there was no traffic, and the trip only took 7 hours. If his average rate was 18 miles per hour faster on the trip home, how far does Miguel live in the mountains? So let me get some information down, then I'll go back to my paper. So we have rate, time, in distance again, but now we have the trip there and back. So we'll just say there and home, because that's what they used in the word problem. So on the way there, the time was 10 hours, and I'll show you my paper in a second. On the way back, it was 7 hours. On the trip home, the rate was 18 miles per hour faster than going to the mountains. So I'm going to say there the rate is x, and home is x plus 18. So it took 10 hours to go there, 7 hours to drive back. He went 18 miles per hour faster on average on the way home compared to going there. That makes sense, because if the time was shorter, he was probably moving an average speed that was faster. Now here's the key. We're going to go 10x here and 7 times x plus 18. And the key here is driving to this vacation spot and driving home, the distance they travel is exactly the same. So what we're going to do is set 10x equal to 7x plus 18. Because driving there and back, they're covering the exact same distance, so we know these have to be equal. So we're going to distribute 7x, we get 56, so we get 126 there. Subtract 7x from both sides, and divide by 3. So divide both sides by 3, so we get 42. And the question is, how many miles does he live from the mountains? It is 42 miles. Okay, so x equals 42. Okay, so same type of chart. So with the train ones, they were moving towards each other. We added these two instead of equal to the total distance, but they gave us the total distance. Here, there was no distance because driving to a place and driving home, theoretically, in an ideal world, are exactly the same amount of distance. So you just set these equal and solve. Okay, so now that we found this x is the rate. So now that we found the rate, well, we know you can plug into either one, but this is easier. So if it's asking you, the question is to find the distance in miles. So to find the distance, we're just going to plug in x, and it'll work for either of these, but this one's easier. So 10 times 42 is equal to 420 miles. So that wasn't the answer, I just needed to get to the answer. So the distance in miles, to find the distance here, we go 10 times 42, or you could have done 7 times 42 plus 18. They would work in either. This was just a lot easier. Okay, so there's our distance in miles, 420. Okay, our last problem in this section, same setup, but it has to do with finding a rate. So let's take a look. Okay, so 2 cars leave towns 380 kilometers apart at the same time and travel toward each other. One car's rate is 14 kilometers per hour less than the others. If they meet in 2 hours, what is the rate of the slower car? All right, so we have the same thing, and I'll show you in a second. We have rate, we have time, we have distance, and we have the slower car and the faster car. And we know the distance is equal to 380. This is very similar to the train problem. So if you want to pause it and go for it, go ahead. I'm going to continue on and show you how to get the answer. So the faster car I'm going to call the rate of x, and the slower car is x minus 14. I got that from here. One's car rate is 14 kilometers per hour less than the other. If they meet in 2 hours, so the time is 2 hours for both, let's find the rate of the slower car. Okay. There's a couple different ways you can set this up. I just chose to go with this one. So slower, faster. Remember they want the slower car, so to come back and get that at the end. So remember, rate times time equals distance. So 2 times x minus 14 and 2 times x, those are our rate times time. So 2 times x minus 14, they're traveling towards each other, plus the 2x equals, they're covering the distance of 380. So 2x minus 14 plus 2x equals 380. 4x minus 14 equals 380. Add 14. And then we're going to take our 394 and divide it by 4. Just caught a mistake. I forgot to distribute here, so we got a 28 here. So 28 here, add 28 to both sides, which is 408. And 408 divided by 4, x equals 102. Okay. So that's the faster car. Pretty fast car going on here. And to find the slower, I'm going to take my 102 and minus 14. So the slower car is 88, I think it's kilometers per hour. So I just messed up, I just missed the distribute there. So when you're working it out, just be careful, check your work, because when you plug in your answer, it'll tell you right or wrong. So that completes our distance, rate, and time problems.